Hello friends, welcome back to channel Civil Engineering Academy. In today's video, we are going to discuss different types of loads acting on structure. There are various types of load studied in the structural analysis. We will discuss that one by one. So the first one is dead load. It is the load that constantly acts on the building despite of any circumstances, and it is nothing but the self-weight of beams, columns, slabs, staircase, sajja and the many other building elements. And these loads are permanently added to the structure and generally referred as a stationary load. Then there are some standard dead load values are given for the different materials, like for cement concrete or the plain cement concrete, that dead load value is nothing but the 24 kilonewton per cubic meter. Then for the reinforced cement concrete, or we can say it is a RCC, it is 25 kilonewton per cubic meter. Then for steel, it is 78.5 kilonewton per cubic meter, and for wood it is 8 kilonewton per cubic meter. For brick masonry, cement plaster, it is considered to be 20 kilonewton per cubic meter. The next is stone masonry, and it is taken as 24 kilonewton per cubic meter. Then floor finish, it is equals to 0.6 to 1.2 kilonewton per cubic meter. So there are the different material having the different dead load values. So this is the list which is most important for any type of a design. Then the next type of a load is lie load. It is also known as an imposed load. This load keeps changing from time to time as they are not permanently added to the structure. Examples of lie loads are human walking inside the building, furniture kept on the floor, equipments, etc. And all these loads are the dynamic in the nature and can be transferred from one position to another. For reference, it is recommended to look in IS 875 Part 2, 1987 for the minimum values of lie load in the residential building, educational building, institutional building, storage rooms, business and office buildings, and the mercantile buildings and the assembly buildings. That means for the different types of buildings, lie load values are given in the IS 875 Part 2, 1987. Like for dead load, it is IS 875 Part 1. For lie load, it is IS 875 Part 2, and likewise. Now the next type of a load is a wind load. It is a load due to the horizontal component of wind that depends upon the velocity of the wind and the shape as well as the size of the building. IS 875 Part 3 deals in the wind load on a building, and basic wind pressure is depends upon the locality of the building. To obtain the design wind velocity and to obtain the design wind pressure, the formulas are given in the IS 875. That referring these formulas, we can design the structure by considering the wind load for high-rise building. We can say till the height of 30 meter, the wind pressure is considered to act as uniformly on the building. But when the height is above 30 meter, the wind pressure increases. And in that conditions, we have to consider the IS 875 Part 3 and the values given in it. Now the next type of a load is snow load. And this is the load caused by the accumulation of snow in the cold climatic areas. These loads are calculated on the basis of snow projections at different parts of the structure, and it depends upon the height, shape and the size of the building. IS 875 Part 4 deals in the snow load for design of buildings, and this load is not the outcome of a single impact but the result of multiple impact of snow. Such a loads cause imbalance on the roof of the structure and hence need to be treated for the safe design of a structure. So this is all about the snow load. For detail, we can check the IS 875 Part 4. Then the next type of load is earthquake load. Dynamic horizontal loads act on the structure in case of earthquake. Hence, seismic design is necessary for earthquake prone areas to reduce the hazard. And IS 1893-2016 deals with such a seismic load, and IS 13920-2016 deals in the details of a structural members that are to be designed in the accordance with the earthquake load. According to the Bureau of Indian Standard, that is BIS, the seismic location in India is divided into 4 different zones, like Zone 2, Zone 3, Zone 4 and Zone 5. So this is all about the different types of loads and loading conditions and their regarding IS course. So all these loads have a different impact on the buildings. Different areas have the different weather conditions, which in turn have the impact on the variety of loadings. Some areas may experience the combinations of loading like dead load plus live load plus earthquake load, or we can say dead load plus live load plus wind load, and many combinations are there. So the several loads combinations are needed to evaluate while designing the buildings, and the maximum load is to be taken into the consideration for the safe design of a structure. So this is all about the loads and the load conditions. Hope you find the content of this video useful. If you like it, please share and subscribe the channel.